Children, welcome to channel Sube. Today I am going to discuss question number 29 of 2019 Physics new syllabus paper, the MCQ part. Two thin spherical metallic shells are placed concentrically as shown in the figure. Inner shell is kept at a potential V while the outer shell is grounded. The variation of the electric field E with distance x from the center is best represented by, there are 5 graphs. Children, what they have given is actually a capacitor. This one is actually a capacitor because this shell is a metal plate. It is made of metal. So it is connected with a voltage like this. The voltage is given by a battery like this. Voltage is given by a battery like this. So the other plate is grounded. But it is not the ground that you imagine that we stand on. It is not the ground that we stand on. So it is not the ground, not this ground. We say ground to the negative side of the battery. In electrostatics, we say ground to the negative side of the battery. So actually the meaning of this symbol is that this shell is connected to the negative side of this battery. So voltage is given by a battery usually. So like this is the structure of this system. So what you learn in the classroom is you learn parallel plate capacitors like this. There are two metal plates which are parallel to each other, and how to charge it. To charge a capacitor, we have to connect it with a battery like this. Positive side to one plate and negative side to other plate. Then what happens? It gets charged like this. So in between these plates there is a insulating material. So that is the structure. So in between those two plates, what do you think there are? There are force lines like this. You must have learned this. There are force lines like this from positive plate to the negative plate like this. Force lines. If there are force lines anywhere, there is a field strength. What is the field strength? What is the meaning of field strength? If you make a frame whose sides are 1 meter, and you place that frame here, then you have to count the force lines penetrating through that surface of the frame. So here in this case there are 2. So E equals 2 then. If you change the place of this frame, if you place that frame somewhere else, here very close to this plate, like this you place that frame, then how many lines? Again 2 you see. So here it is 2, E equals 2. Here earlier we discussed E equals 2. So along this distance in a parallel plate capacitor, E doesn't change, field strength is constant. So like this is the suitable graph for such a system. And also I have to remind you that outside of these plates there are no force lines. Therefore E equals 0. If there are no force lines, equal 0. So that also you must keep in your mind. So let's now go to our problem. You can simplify this capacitor, this spherical system, like this. You can only imagine only a section like this, only a section like this. So this section. So inner plate is connected with the positive of the battery. They have given it is V, the voltage is V. So the other plate, the outer plate is connected, the symbol is there, grounded. They have said it here, the grounded, they say it. So this is the simplified figure, this is the simplified diagram. So how is the field, how is the force line, how are the force lines distributed? Force lines are like this, because always force lines are perpendicular to the plates. So force lines are like this here. Force lines are like this. So you have to do the same experiment with that frame I earlier explained to measure capital E, measure the field strength. Then you can understand how does it change. So you can place the frame whose sides are 1 meter here first. Then how many lines? 2. Then that means E equals 2. Then you move the frame to here and you place that frame here. Now how many force lines? 1 equals 1. What has happened? The field strength has decreased. Field strength has decreased, but it is not 0. It is not 0. It is 0 outside of this plate, outside of these plates here, and also here it is 0. But inside it is not 0. It decreases. So you can select this one and this one, because decreases, not 0, not 0. But this one you can't select because 0. Because this one also 0. You can't select this thing. These two, they are wrong. And what is the knowledge you have about the field strength in a shell? So the inside of this shell. What do you know about that? What is the value of E? You must know inside of a metallic shell, inside of the shell, field strength is 0, because there are no force lines. Inside there are no force lines. Why we say so? When we connected the battery positive to this spherical, the sphere, to this sphere, what happens? Positive charges accumulate like this, only the outside of the sphere. Why can't they go inside like this? Why can't they gather inside? Because they are repelled each other. These two are enemies, they repel each other. So this one can't go anywhere, therefore it stays here. But this one jumps out to the outer surface. It can't stay inside. So therefore there are no charges inside of a sphere which is connected with the battery. So there are no charges inside. If there are two charges inside, what happens? Both are enemies. This one jumps to this outer surface, this one also jumps to this outer surface. So finally we can see they are here outside. Furthermore, if we connected the wire, this one doesn't stay here, it further goes to this one and stay here. This also goes along the same wire and comes to this way, because they are enemies, they repel each other. They finally stays like this. They finally stay like this. Finally we can see they like that. So therefore there are no charges inside, and also there are no force lines inside. Only force lines will be seen like this, inner shell to outer shell only. Inner shell to the outer shell only. The force lines are only available in this region. No inside, no force lines outside, because if an electron begins to flow like this from the negative, it will come and it will stay here. Therefore there are no force lines outside of these shells and inside of inner shell. So the same thing you can identify, same thing I explained earlier. Here this thing is equal to this section. So now you know the inside E equals 0. Therefore inside is this region. X values are smaller than R. X values are smaller than R. Like this is small values. Here X is equal to R on the surface. When we take a point inside this shell, the X value is smaller than simple R. Therefore this is the region. So this one is wrong because it has a value for E. So therefore this one is wrong. But this one is correct because E is equal E is 0 as I explained inside of the inner shell. Inside of the inner shell E is 0. So suitable answer is this second one. So children, I think I explained so that you can understand. I don't know. However, I explained everything. First thing, you should not misunderstand that this symbol is not the ground where we stand on. It is not the ground where we stand on. It is not the ground where we stand on. Even though we use the word ground, the ground of this power supply, is negative. Why we say so? All the positive ions fall down to, all the positive ions drop down to, if we connected a wire like this, all these positive ions drop down to this place and finish. So therefore this negative plate is the ground for this battery. Therefore we call it ground. Not to where, it is not the ground that we stand on. That is different. So we say ground to the negative side, negative terminal of the battery. So therefore if you misunderstand that symbol, you will not successfully select the correct answer. So children, thank you very much for watching my videos. Keep watching again and again. If you are happy, subscribe my channel. See you tomorrow. Goodbye.